Okay. Probably the last couple of house cleaning things we need to make sure we do or make sure we explain. Regardless if you do the homework or not, regardless if you do or not, the late one shows up. Okay. I had several students confused, like, why does the late one there when I did the first one? Okay. So the late one's there because the first one's gone, right? It should disappear. And so some students like to go back and look at the homework problems just to kind of get a refresher for some of those. Okay. If you go back and look at them and even answer them, it's not going to over trump your previous grade, right? So out of the two homeworks, I'm basically giving you the highest out of the two, truth be told. Okay. So if you already have a 5, I don't care if you look at it or don't look at it or answer it or don't, it doesn't matter. If you only have a 3 or a 2 and you do this one and you get a 5, then I'll give you the 5. You okay with all that? Good. On homeworks, the last couple of questions are typically multiple choice type questions. Those are AP style questions. So all the homework questions up to that are just kind of knowledge based, making sure you understand things. Those last couple, and you'll know them, they're just numbered. They're just numbered. Those are like AP style questions. Okay, AP style questions. Sorry. Oh, still got you. You're in a really bad spot. Okay, so that's homeworks. 4.2, I apologize. I didn't realize that one as long as it was until I'd already assigned it the first hour and I said, oops. So I should have fixed that, but that's okay. I don't think there'll ever be another one that long. And if there is, then bad teacher. We're going to discuss 4.3 today. Anybody got any questions over anything that need a little clearing up or something? Somebody sent me a question on one of them, and several of these actually have videos that they work the problems out. I don't say all of them, but there are several of them. And so if you get confused by a whole lot and I find the video on it, I'll just assign you the video and hopefully that it will clear it up. If it doesn't, then I try to do my best to clear it up. These are, I can't say I don't like this chapter, but I don't. There's so much reading and I hate reading. And there's so many little tricks and they throw in there and things. So the basic knowledge, right? How you're going to sample and how you're going to assign. If you get that, you're pretty good with all this stuff. Today's lesson, 90% of it's not on the test. Maybe 95. It's not a whole lot. I'll make sure you know what you need to know for it. What this one is guys, this one really sets us up for this class. And they start asking you things and start talking about things. We talked about it even day one, about likeliness and the unlikeliness of things to happen and all that kind of stuff. That's kind of where this is going. This is really this is more of a get you to thinking, and like in the future, it's going to come up again. And like, remember when we talked about this? Remember when we talked about this? And so it's kind of those things that kind of just get you going a little bit. Hopefully it helps you, like I said, more later on than it really will right now. So here we go. We'll get through it. And then we got some other things for you via work. Click, click. Oh, you're going to not do it again. Oh, I love this thing so much. To think. Like I get here at 10 till 6. I'm still not ready. Aha, here we go. Using studies wisely. Inference for sampling. Okay. When members of the sample are selected at random. So that's the big thing that they're talking about right here. When they're selected at random. Sometimes we don't select them at random. Sometimes we have volunteers. Those are not selected at random. When they're selected at random from the population, we can use that sample to make judges or make inferences about the entire population. So if you guys are my population and I take a random sample and I get the GPA of that random sample, I should be able to come close to making a judgment to the population. Should, right? If it's random. Because if it's random, that should help reduce a lot of the bias. Okay? That is, we can make inferences about population from what the sample is randomly selected. Inference from convenient samples, voluntary, would be misleading because these methods of choosing samples are typically biased. And we've talked about that, okay? In these cases, we're almost certain that the sample does not represent the population. Remember, it's biased because it either overestimates or underestimates the truth, okay? So kind of keep always that in your head. We already talked about that. Here's sampling variability. Again, this is not going to be on your test, but this is something that we're going to talk about. Chapter 7, for sure, that like really starts talking about a lot of things happening. And it's really, 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 really common sense. So we know what sampling is. We know what sampling is, right? We gather samples, or one sample, whatever we might do. And then variability, that's a word that gets used a lot in this class. How much does it vary? Okay, variability, it varies, yada, yada. So sometimes it varies a lot, and sometimes it doesn't vary a whole lot. Okay, so variability. So here's what the definition of sampling variability is. Different samples. Different samples. So if I take a sample, and I take another sample, or I take another sample, different samples of the same size. So I'll take a sample of 3 from this classroom. I'll take another sample of 3 from this classroom. I'll take another sample of 3 from this classroom. So different samples of the same size from the same population, if you were my population, produce different estimates. Duh. Different samples of the same size from the same population produce different estimates, different values. Different samples of the same size from the same population produce different values or different estimates. Again, this is really, really, really common sense, I would think. You guys are my population. You guys are my population. I throw all of your names into a hat and I mix them up and I pull 3 names out without replacing them. I got 3 names. I'm going to grab those 3 people's names and I'm going to find out the GPA of those 3 students. 3.75. I put those names back into a hat and I mix them all up and I pull out 3. I could pull out the same 3, but I'd be really, really, really surprised if I did. But the different 3 that I pull out is probably not going to be 3.75. In fact, I'd be more surprised if it was 3.75 than if it wasn't 3.75. Is it going to be close to 3.75? Well, it just kind of depends, right? It kind of just depends on certain things. I figure it to be close to that because I don't figure there's going to be a whole lot of variability in this classroom. I don't think there will be a whole lot. Okay with that? But that's what they're saying with this, sampling variability. So we understand that a different sample is going to produce a different value from sample to sample to sample to sample. If by some crazy chance that one of my samples was 3.75 and the second sample was a 1.25, wow, that's a big difference. So now I'm starting to think something happened on one of those samples, more than likely. Something happened on one of those samples. Okay, neither here nor there. We could do it with weights, how much you weigh, right? So the average weight. So I pull 3, I find the average weight there. I pull the next 3 and I find the average weight there. That probably does have a little bit more variability than maybe even the GPA, because GPA can only go from 1 to 4, whereas weight can go from 100 to 200, or some of you guys maybe 80 to 200. Larger samples, larger sample sizes, larger random samples, larger sizes tend to produce estimates that are closer to the truth. Larger samples produce estimates that are closer to the truth. Again, this should be somewhat common sense. Big type picture, larger samples produce estimates that are closer to the truth. If I take a random sample of 3, if something is abnormal out of those 3, it has higher weight mathematically, right? If you have an 80 and an 80 on a test and you bomb, you got a 40, that 40 is really affecting those 80s. As opposed to if you have an 80 and 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 a 40. Now it's not affecting those 80s as much. It's still affecting it, but not near as much if there was just 2. So the larger the sample is, if I decide to not take a sample of 3 and I decide to take a sample of 6, or maybe let's even go 8, If I take a random sample of 8 of you guys, that GPA from those 8 is going to be closer to the truth. If I take a random sample of 30, I have a census. Of course, we know how accurate censuses are anyway. They're not very accurate. However, probably more accurate than a sample of size 2. Y'all good with all that? Again, common sense type stuff, but big picture. In other words, estimates from larger samples are more precise. Don't say the word accurate. I mentioned that earlier. Right? More accurate. If I take a random sample of these 3 guys right here and I get their GPAs, that's their GPA. It's not accurate or inaccurate. I mean, I guess the only way to be more accurate is if I took it out 2 more decimal places. Right? That's that value. It's not more accurate or no more closer to, it's more precise. It's closer to the population value. It's not more accurate. I don't know if this is a great example or not. They say you could teach this entire class with a jar of M&Ms. How would you random sample, right? Separate them. Would you put peanuts and non-peanuts like the plains? Okay, so we got a jar of M&Ms or beads or Skittles or whatever you want to talk about. We got a jar full of them, right? You all know M&Ms have all these different kind of colors. N is 20, so N is telling me that's the sample size. So whenever you see a little n equals something, that's how big of a sample we're getting, okay? So the one that I've been talking about, n is equal to 3, or n is equal to 8. So n is equal to 20. So I'm going to pull out 20 of those jelly beans. I'm sorry, I got M&Ms. I'm going to pull out 20 of those M&Ms. I'm going to see out of those 20, what percentage of those jelly beans are red? What percentage are red? Okay with that? I'll tell you that the national average, or M&Ms, tells me that the national average, or the average, is somewhere around 31% of all M&Ms are red. Peanut M&Ms are red, 31%, somewhere in there. So my sample should come close to 30%. It may or may not. I decided to do this, I don't know. How many dots are up there? 50? 100? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe 50. Let's say 50. 50 dots up there. I did that 50 times. So I pulled out 20 M&Ms and I got whatever percent they were red. I put them in, I mix them all up, and I pull out another 20. What percent of those were red? I put them in, mix them all up, pull out another 20. Y'all okay? I did that 50 times. We'll never do this in class. In statistics, we do it once. We do one sample. It came up 30% most of the time, which is probably what you would expect if that's the national average. However, sometimes we got down here to 10%, and sometimes we got all the way up there to 50%. Out of those 20, 10 of them are red. That happened once. That's kind of weird, but it happened. Possible, not likely. Never came up more than 50%. Y'all okay with good enough? Good, good. Okay, put them back in, mix them all up. Instead of pulling 20 out, I pull out 100. What percent of those are red? It looked like that. Still, most of them are right around that 30%. However, what do we notice? That variability is a whole lot less. We never even got down to 20% because it's very unlikely to get further away from that 30 as your sample size increases, right? I mean, in order to get out of the 100, I have to get 50 red ones. That's pretty hard to do if the truth is 30%. Okay? Y'all good with all that stuff? Again, just kind of showing this. So this is what we're going to call sampling. This is kind of a distribution of samples. That's what we'll call that. 50 samples. That's a distribution of 50 samples. So that one dot right there is the percentage of red out of a sample of 100. So each dot is a percentage of reds out of 100 in that one simulation. Good? You see some pictures like this. Some students have a tough time seeing all this. I'm doing a much better job than I am now. That's why I'm recording it. How much do national football players weigh on the average? So we have the NFL. NFL's getting ready to kick off with a real season here soon. How much do the average football player weigh? We took a random sample of 50 NFL players. There's a whole lot more than 50. In fact, there's more than 50 on one team. We took a random sample of 50 of them and found their weight to be 244.4. Good enough with that? Do you think that 244.4 is the true average of all NFL players? I'd be really, really, really surprised. How close is it? Don't know. Don't know, but that's what we got in our sample. Okay? I could have got 50 linemen, and now I'm overestimating. I could have got, I don't think I could have got 50 receivers, but I could have got receivers and skill positions, and now I'm really underestimating the truth, right? Because I only got 50, and there's all, like I said, there's a whole lot of NFL players. 50 that might cover one team, and there's 36 teams. No, different samples of size 50 is going to produce different values. Not only is it going to produce different values, but it's probably different values than the truth. How far off? Don't know. That's why we do statistics. A lot of times we don't know. The only way we'll really know is if we did every single one of them, and even then we don't know how accurate we're going to be. Good? Easy enough. Which is going to be more likely to give an estimate closer to the true weight? A random sample of 50 or a random sample of 100? The random sample of 100. Because as you increase the sample size, you get closer to the truth. Right? It's hard if out of a sample of 100 for all 100 of them to be offensive linemen. Now, possible? Yeah. Hard. Okay? I've probably got some skill players in there somehow, some way, some form, some fashion. How could we do that better? Stratify them. Stratify them. Stratify them by position. Randomly select from the positions. That way I'm guaranteed to get some from each. What's the disadvantage of that? Takes too long. Takes too long. And if there's more linemen than there are receivers, so now I'm putting the same weight on receivers as I am linemen. So I might actually want to select more linemen, like a representative. Now you're starting to really start thinking too much about it. A random sample of 100, that gives me estimates that are closer. So now we know that random selection lets me produce or lets me guess or lets me infer to the entire population. Random assignment, well-designed experiments allow to show cause and effect. That's the only way to show cause and effect. It has to be an experiment. It has to be an experiment. And that's the one, again, they don't really want to try to trick you, but that's the one I say that they're going to try to trick you with. They're going to make you believe that because we watched all this and we saw all this, that you should eat carrots. Statistically significant. Statistically significant. When an observed value or observed result, or what we got, right, out of those 20 M&Ms, the percent that we got red, right, when the observed value is too unusual to be explained by chance alone. When the observed value of a study is too unusual to be explained by chance alone. I don't know if that's really the best wording, but it's the best I got. When the observed results are so weird, we got to say that that is statistically significant. M&M Mars tells us that 30% of the M&Ms are red. We took a sample of 20. Half of those were red. That happened one time out of the 100, which is or out of 50. One time out of 50, which is like 2%. That's unusual. That's statistically significant. One of two things happened when we get something that's so far from the claim. I'll hear the word claim, right? The claim was 30%. That's what they're saying. When I get something that's so far away from the claim, one of two things happened. You got a bad sample. That's why we learn how to sample well, or their claim is wrong. Their claim is wrong. Okay with that? And so because we know how to sample well, we don't think we got a bad sample. However, we could have, but we have to think that their claim is wrong. That's statistically significant when you're so far away. If I would have gotten 50% on this one, I'm really thinking I'm statistically significant because it never happened. It never happened in any simulations. Is it still possible? I mean, if there's 50 red M&Ms in there, I guess it's possible. There may not even be 50 in there. Statistically significant when the observed value of my sample is so far away from the truth or so far away from the claim. Okay? Is talking on a cell phone while driving more distracting than talking to a passenger? So you're driving in a car, you're talking on a cell phone. Is that more distracting than if I have a friend in there? That's what they're asking. David Strayer and his colleagues at the University of Utah designed an experiment to help answer this question. So we got some people, we designed an experiment. They tell us more about it. They used 48 undergrad students as subjects. They didn't tell me how they got these 48 students. I wish they would have told me they randomly selected 48 students or somehow or another. 48's not that big, but they got 48 of those cats. The researchers randomly assigned half the subjects to drive in a simulator while talking on a cell phone. The other half to drive in a simulator while talking to a passenger. Man, they removed a whole lot of confounding variables. Because by putting you in a simulator, everybody does the exact same course, right? You're not actually, hey, go to Rogers barbecue joint, right? You got traffic to worry about. You got stoplights to worry about. I mean, there's all kinds of things that could affect that. So they put them in a simulator. That way, everybody has the exact same story, okay? Half of them talking on the phone, and the other half are talking to a passenger. One response variable was whether or not they stopped at a rest area. It was specified by the researchers before the simulation started. So before it started, they said, hey, you need to stop at this rest area. Okay? Here's the results. The response, they either stopped or they didn't stop. And the treatment, they were either talking on a cell phone or they were not talking, or they were talking on a passenger, right? Here's the 24 cats, and here's the 24 cats, and here's all 48 cats. 33 of them stopped, 15 of them missed it. Of those 33 that stopped, 21 of them were talking to a passenger, but only 12 of them were talking on the cell phone. This is half and half. This is quite a bit more here, did what they were supposed to, than here. It looks like talking to a passenger, it looks like it's less distracting, according to this data. Okay? Just kind of soak all that in. Calculate the difference, passenger minus cell phone, in the proportion of students who stopped while talking on the cell phone. So, the proportion of who stopped while talking on the cell phone. While talking to the passenger and the cell phone. The proportion. So the proportion who stopped is 21 out of 24. 21 out of 24 stopped with a passenger, and 12 out of 24 stopped while talking on the cell phone. Okay with that? Again, if you don't understand this, it's okay. I just finally get to do some kind of math. That comes up to 0.375. In statistics, they don't care if you leave things as fractions. They don't care if you put them as decimals. They don't care if you put them as percentages. We typically don't put them as percentages because you get tired of writing the little percent symbol. I don't like fractions because fractions might reduce. Typically, we put things as decimals because fractions don't mean a whole lot to me. 0.375 does. That's 38%. Okay? Now, what does that 38% tell me? It tells me that you are 30% more likely to stop while talking to a passenger than while talking on a cell phone. You're 38% more likely to stop talking to a passenger than you are talking on a cell phone. That's a pretty big number, but that's okay, whatever, here and there. Everybody good? Okay? All right. So here's what they want to try to prove. They want to prove that it is significant. They want to say that, hey, these numbers are these are statistically significant, that the difference is 0.375. So here's what they're going to assume. They're going to assume that there's no difference. They're going to assume there's no difference. So they're going to assume that there's a 0% difference between the two. Okay with that? So if there was a 0% chance, they're going to do some simulations simulating the exact same thing. Somehow, some form, some way, some fashion. I don't think they tell me how they did it. 100 trials of simulation were performed to see what the difference in proportions would occur due to chance variation in random assignment, assuming that the type of distraction did not affect it. That is, 33 stoppers and 15 non-stoppers were assigned to the group of 24. So I guess they have 24 things in there, and you had 33 stoppers and 15 non-stoppers. I don't know. Just play along. That's what it looked like. That's what those 100 samples look like. Notice that 0 is right here. A lot of you probably can't see that because it's too low and it's really, really small. So 0 is right here, which happens most of the time because we're assuming there's no difference. So if we're assuming that's no difference, that should happen most of the time. We assume that 30% is true. That happened most of the time in my red M&Ms. Sometimes we didn't get 30%. Sometimes we didn't get 0%. Ironically, the ones we didn't get 0%, the ones that didn't get 0% are pretty close to 0. And then sometimes we even got all the way out here to like 0.3% negative. That meant that the cell phone was bigger. That meant the passenger had more of effect. In the negatives, the passenger had more effect. Right? It was passenger minus cell phone. Whereas over here, the cell phone had more of effect. Okay, y'all kind of recognize the distribution of this. That's 50, or not, I'm sorry, that's 100. That's 100 dots. So here's what their question is. If you can understand this, it's going to get you through about the next, well, I don't know, rest of the year, because they're going to ask this type of question a lot. There are 3 dots at 0.29. 3 dots at 0.29. Explain what these dots mean in the context of this problem. So I'm going to state, assuming there's no difference. Assuming there's no difference. 29%, 3 times. How about that? 3 times out of the 100, we got a difference of 29%. That's what those 3 dots mean. When we assume it doesn't matter, we assume there's no difference. We assume that it doesn't have effect on either one of them, right? There's 29 different ways of saying it. We assume there's no difference. We assume that they're the same. We assume that it didn't matter. There were 3 times, 3 simulations, 3 times out of those 100 where the difference was 0.29. Okay? And you can say that however you want, but you're going to be asked something very, very, very similar to that. Guys, that is a definition that 100% will be on your AP exam. It will not be on Chapter 4 exam. But that's a definition that will be on your AP exam. We will hit it hard starting January. Okay? We actually probably don't get till February. But that's what those 3 dots mean. 3 times we got 29%. Y'all remember what our difference was we got in the true? Was it 38%, 37.5? Which is like out here. Where we start thinking, we got a bad sample, or that's false. There is an effect on it. That is statistically significant. Use the results of the simulation to determine if the difference is statistically significant. Because my 0.38 or 0.375 is so far away from any other result, yeah, because a difference of 0.375 or greater, they throw that in there, We'll talk about that later. I'm not too concerned that you know it's or greater. Never occurred in the simulation. It didn't even come close to occurring. The difference is statistically significant. It is statistically significant. It's very unlikely for that difference to happen by chance variation, given that there's no difference, yada, 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 yada. Again, none of this is going to be on your Chapter 4 test. It will have your homework questions on it tonight. They're really trying to talk about things being statistically significant, and if they're not. If they're not statistically significant, we expect those results to happen. We expect that chance variation to happen from sample to sample to sample. Okay? All right. Yep, you bet. This you need to know. Random assignment allows me to, random assignment allows inference. Okay, there's that word, inference. Random assignment allows inference to the population. Random selection allows inference to the population. If you randomly select, you can infer to the entire population. A lot of times I've told you guys what they use volunteers, right? Volunteers, it's hard to judge to the entire population. You could judge to people like that, but you can't judge to the entire population. Random assignment allows me to show cause and effect. You don't have to have random selection to still do an experiment. You don't have to have an experiment if you have random selection. You don't have to do both of those, right? You could only do one or two or neither. I mean, if you do nothing, then I don't guess you're doing anything. Okay with all that? So just recognize, was there random selection? If there was random selection, we can infer to the entire population. Was there random assignment? Now we can show cause and effect. If there was random selection and random assignment, we can show cause and effect to the entire population. Okay, and so they're going to give me a quick little table right here, but that's what that's inferring. Go, go, go. Too fast, sorry. I don't know what's going on there. Here we go. So were they randomly assigned? Yes or no? Were they randomly selected? Yes or no? If they were randomly selected and randomly assigned, I can show cause and effect for the entire population. If they were not randomly selected, but are still randomly assigned, I can still show cause and effect. I just can't judge it to the entire population. If they were randomly selected but not randomly assigned, I can make inferences to the population. I just can't show cause and effect. And if I didn't do anything, then we're not doing any one of the two. Y'all okay with those two things? Recognize it. Recognize it in the story they're giving you, right? Was it randomly selection? Was it random assignment? I hope, guys, you can explain the concept of sampling variability, making inferences about the population. However, that will not be on your Chapter 4 test. I hope you can explain the meaning of statistically significant. I hope you can. It will not be on your Chapter 4 test. Identify when it's appropriate to make inferences about the population and when it's appropriate to make inferences about cause and effect. You probably need to know something close to that. Evaluate when a statistical study has been carried out in an ethical manner. I don't know what that actually means. Making sure that if you make them do something, they're not dying, I guess. Yippee, yippee, yo. Okay, so here's where we're at with you guys. You guys are getting hosed, right? You guys are getting hosed a little bit, but it happens. It's 50-50 shot. So you're getting hosed in the fact of today is Thursday. Tomorrow's a B day. Saturday, Sunday, Monday, Tuesday's your next B day. I'm done with a chapter. Tomorrow's a review day. Tuesday's your first chapter test. Okay? Mostly 4-1-4-2. Mostly 4-1-4-2, not very much a 4-3. Okay? You need to know this, 4-1, 4-2, 4-3, and there will be a 4 review in Achieve. 4-1, 2, 3, and a review in Achieve. I'll post it sometime tonight or first thing in the morning. Okay? So those are the 4 assignments that you have to do for grades. If you don't do those, then you'll end up taking a final for me. Okay, with all that, right? I have all of those due on Tuesday. Even the late ones are still worth 5 points. We give them some grace for the first couple of chapters. After a while, the late ones will start being worth 4 points. Okay, everybody okay with that? Now, I am going to go ahead and give you 2 worksheets. You can do them or not. I don't care. First worksheet has some true false on there. It has a bold word. If it's true, it's true. If it's false, make the bold word true. There's some words on here that we probably didn't discuss a whole lot in class. The first one, sampling frame. I didn't discuss sampling frame. I got to put that in my slide or something. It just shows up here. But a sampling frame, so if you guys are my population, a sampling frame is a list of all you guys somehow, some way, some form, some fashion. It's a frame. It's putting everybody inside of it so I know how to select it. That's a sampling frame. Then there's a couple, identify the type of a source of bias. More than one could occur, but they're just kind of wanting you to think about what the bias was. Remember what bias is. It overestimates or underestimates the truth. Okay? And then what we got here, what type of method was used to select? And we got a couple multiple choices here. And then the second one I'm going to give you, and you can do it or not do it, I don't care. The second one I'm going to give you is just a front. It has 3 previous AP questions from this chapter. Okay? They're from a long time ago, 97, 99, and 2000. And the main reason for that is I don't go that far back to find questions for you guys. Right? I don't go that far back. But anyway, that kind of at least gives you an idea of what type of question you might see on Tuesday. There'll be 2 free response questions. I think there's 2 or there's either 2 or 3, or there's 2 full free response questions and a couple fill in the blanks. I'll tell you for sure tomorrow because I hadn't made it yet. What was I getting ready to tell you about? Oh, and then tomorrow. So tomorrow's a I don't want to say free day. Tomorrow's a review day. Okay? Tomorrow's review day. So do what you need to tomorrow with your buddies. I like for you guys to work together tomorrow for reviewing. Statistics is a group effort. If you talk statistics, you're more than likely to do better. I will post the review in the book. And then I also, on Google Classroom, I have, good gracious, 40 multiple choice questions. Again, they're all practice. It's all practice, but it's a Google form. So I'll give you the question. I'll give you A, B, C, D, or E. Those are your choices. You always have A, B, C, D, or E in this class. They're getting ready to change it to just 4 choices, but not yet. So it's 5 right now. Okay? You can answer it or not answer it. I really don't care if you answer it or don't answer it on the Google form, but when you hit next, it gives you the answer and it explains it. So it's kind of nice in the fact that you don't have to look at the answer and maybe accidentally look at the next answer and that kind of stuff. Okay? And then you hit next. And so they're in groups of 10. They're in groups of 10. We'll talk all about that tomorrow too. I'll post all that sometime today. Everybody okay? I'm going to hit stop on this. Y'all good. Work on 4-3, work on